Welcome to installation and removal of flanged valves. During this program, we're going to show you how to correctly and safely install and then remove this valve in the run of pipe. This is a task you will repeat many times in your day-to-day work in the plant. The first point we want to make concerns the flanges. As mentioned, we are dealing only with flanged valves, not threaded, welded, or any other type. This is a flanged valve. The valve is installed in a line that has flanges on the ends of the pipe. These valves are installed with bolts and gaskets. A flanged valve will function properly only when installed correctly and in a line with the same flange rating and flange size. The valve's flanges and the pipe flanges must be of the same size and rating and also be of the same type. As you tighten the bolts, always use the crossover method of tightening. This will pull the flanges together equally all around. Be sure you don't miss a single bolt. It's possible on very large flanges. It's a good practice to go over the bolts after the initial tightening using the crossover method. This second time can be done in rotation. This illustrates the proper sequence of the crossover method of tightening the flange bolts. The sequence of the numbers is not critical, but the crossover sequence is necessary to tighten the flanges correctly. In industry, valves, flanges, and pipe are standardized. They are standardized by pipe size, pressure of the line, types of flanges, and by design. You must install the right valve in the line. A book, as shown, gives all the information to help you decide which is the right valve. For instance, you can't install a 150-pound rating valve in a line that has 300 pounds flange ratings. And you can't install a 4-inch valve in a 6-inch line that has 6-inch flanges. Make sure you have the right valve for the line you're working on. This is the most commonly used flanged valve in our plants. It is a raised face flanged valve. It has a 1/16 inch raised surface that matches the raised surface of the pipe flanges. This type of valve is installed with a flat gasket between the two raised surfaces. The raised face flange requires this type of gasket. It is ring-shaped and is about the same size as the raised surface of the flanges it's used with. The type of gasket is determined by a number of different factors, including the pressure, size, and type of flow of the line. The selection of proper gaskets is very important. Always be sure you install a gasket with the correct specifications. The other basic type of flange on valves looks like this. It is a ring joint flanged valve. The face of the flanged valve has a machined groove. Ring joint valves are generally used for lines with high pressure or more corrosive contents in the line. The gasket used in ring joint flanges looks like this. It is a metal ring machined to fit the groove in the flange exactly. It is extremely important that both the ring and the groove are clean during installing. Ring joint gaskets are also standardized and will fit the groove in the flange for which it is made. Before we show you some types and characteristics of valves, we have some questions for you to answer. Turn to exercise number 1 in your workbook. There are 4 basic types of valves used in our plants. They are the gate, globe, control, and check valves. Each one has its own characteristics regarding installation. Each type of valve must be installed in a certain way. The first type, and the most common type, is the steel gate valve. Gate valves are used for blocking a line. As the name implies, it has a steel gate that opens and closes to stop the flow through the line. The gate valve would normally be either completely open or completely closed. Gate valves do not need to be installed in any specific direction. They can work well regardless of the position of the stem. The valve can be turned so the stem is in any direction required. Be sure to follow specific instructions on each job to determine the correct valve position for that particular installation. The second type of valve is a globe valve. This valve is used to regulate or throttle the flow in a line. The globe valve can operate partially open or closed. Generally, globe valves are longer, face-to-face, than gate valves. They are used in bypass lines and around pumps and turbines where the flow is to be regulated. Now, here's the main difference between a gate and a globe valve. The globe valve must be installed only one way in a line. These valves are generally marked with an arrow or some other indication showing which direction it is to be installed in. The globe valve must be installed with the direction of the flow of the line. In a sense, there is an inlet flange and an outlet flange. As with the gate, the stem direction does not matter, only the direction of the flow. You must know the direction of flow in the pipe to correctly install a globe valve. This is the third type of valve, a control valve. It operates along the same lines as the globe valve. The main difference is this valve is automatic. It is actuated pneumatically or electronically by instruments. The control valve also must be installed in the proper direction with the flow in the pipe. Check the markings or instructions on the valve for installation. The control valve is normally installed with the stem in a vertical position. Again, you must know the direction of flow in the piping to correctly install a control valve. The fourth and final type we will show you is the check valve. It works on the same principle as a one-way door. If pressure on the downstream side of the valve becomes greater than the upstream side, the valve will close and prevent the flow from backing up in the line. This valve also must be installed in the line according to the direction of the flow. It won't work the other way. Install the check valve according to the markings on the valve itself. This type of check is called a swing check and is installed in the horizontal position with the top of the valve up. That concludes this segment on the four basic types of valves. All four are installed with the same general methods except for the specific characteristics related to each valve. All are flanged valves and will fit pipe flanges of the same rating and size. We will show you the actual installation after you complete the questions in exercise number 2 of your workbook. Now, we will show you the proper methods and procedures for the safe installation of a flanged valve. The valve we are installing is the most common of all, the standard steel gate valve with raised gasket faces. The first step is to secure a work permit for the job and to find the exact position in the pipe run where you will be installing the valve. Since this is the gate valve we will install, we do not need to know the direction of flow in the pipe. For all other types of valves, this would be necessary. Now, assemble your tools, equipment, and material. This will include the proper valve, gaskets, bolts, and nuts for each flange. Be sure you are wearing the required safety equipment as necessary. This should include gloves, goggles, hard hat, and we suggest safety shoes. Your plant has its own standards on safety requirements, and you should follow them. Now clean the flange faces on the pipe. Use a flange scraper and wire brush if necessary. Any foreign material, such as rust, scale, and dirt, should be removed. Look for nicks or cuts in the gasket surfaces. Also clean the faces of the valve. The gasket surfaces should be given close attention. They should be clean and free from any foreign material. You now should be ready to install the valve in position. Remember, at some time before or during installation, you must lubricate the stem, gland, and packing bolts. Check the packing bolts to be sure they are holding the gland securely against the valve packing. If it is not tight enough, tighten the bolts to prevent any leakage. The valve here is a 4-inch, 150-pound raised face. Use a sling and rig up the valve to raise it into position. Most of the valves of this size and larger are quite heavy. They require hoisting or even motorized equipment to handle them. Raise the valve carefully to the position of the pipe flanges. Notice how the valve stem and operating wheel are positioned. Guide the valve into position between the pipe flanges. Be sure you know what position the stem is to be in ultimately, and install one bolt in each side of the valve directly opposite each other. These two bolts should be mounted in the correct holes so that when the valve is rolled into place, all of the holes will line up properly, and the stem will be correctly positioned. Put these two bolts in loosely. Do not tighten them at this time. Use lubrication on the bolts as required by your plant. Now, roll the valve on the two bolts until the stem is where you want it. All of the bolt holes must be lined up correctly. The only trick to this method is to place the bolts in the proper holes during the initial installation so the valve will roll. This is called rolling a valve in. On small valves, this can be done by hand after the valve is first bolted to the pipe flanges. Now take your drift pin, pin bar, or pin wrench and insert it into one of the top holes to align the holes more precisely so that the bolts can be installed. Use enough caution so the gasket faces of the flanges will not be damaged. After the holes are aligned, you can install the bolts and nuts on the bottom and side of the flanges. This is to hold the flanges in alignment, and these bolts should be loosely installed. Do not put the top bolts in place at this time. Now, you must open the flanges far enough to insert the gasket between the faces. You can do this with a wedge if necessary. Caution, be careful where the wedge is placed. Don't drive it into the gasket faces, and leave enough room for the gasket to be inserted. Use a flange scraper or other flat tool and align the gasket properly with the flange faces. Try to center the gasket on the flange faces. Now you can see why the bottom bolts were installed first. They help hold the gasket as you position it. Remove the wedge and install the remaining bolts and tighten all the bolts hand tight. Just tight enough to hold the gasket in position and the flanges in proper alignment. Notice, all the bolts are not installed on both sides of the valve. This method is not required because sometimes it is just as easy to put both gaskets in at the same time. Repeat the procedure and install the second gasket between the other two flanges. Be careful to align the flange faces properly and install the bolts remaining as before. Your next step will be to tighten two bolts, one opposite the other, on both sides of the valve. Again, care must be used to properly align the pipe flanges with the valve flanges. Tighten these bolts enough to hold the valve in place securely. Now tighten the rest of the bolts on both sides of the valve while maintaining the proper alignment of the flanges. Be sure each nut on each end of the bolts has a full thread. Always use the crossover method to tighten the nuts on the bolts. It will be necessary to adjust the bolts to be sure each nut is fully threaded. If the bolts are longer than required, it is good practice to take up a full thread on the valve side of the flange and let the extra threads project through the nut on the pipe flange side. Look over the installation carefully. Be sure nuts have full threads and every bolt is tight. Also look to see if the flanges are still in proper alignment. To make it simple, check your work. You have seen a gate valve installed. The only task left is to pick up your tools and material and clean up the work area. No job is completed until this is done. The removal of this gate valve is almost a reverse procedure of the installation. The program will now show the methods to correctly and safely remove the valve. There are some important points to remember about removing the valve. As with all tasks, you must secure a work permit. Locate the exact valve to be removed and assemble the tools and equipment for the task. Be sure you are wearing the proper safety equipment as required by your plant. If the line you are working on has contained toxic gases or sour stock, you should also wear an air-supplied respirator in the positive pressure mode. It is safer to be sure the valve is in the open position when you begin to remove it from the line. Open the valve at this time if it is not open. It is also safer to loosen the flanges on the side of the valve opposite you first. Leave the side next to you tight until the first pair of flanges is opened. This will allow any material in the line to be directed away from you when the flange opens. Assume a safe and comfortable position for the job. Treat every line as though it were full of dangerous material under pressure. First, loosen the lowest bolt on the side of the flange opposite your position. Leave the bolts loosely in the flange at the time. If the line does contain pressure, the flanges will have to be closed in a hurry. In this case, it may be too slow to put the bolts back in place. After loosening the first bolt, loosen the lowest bolt on the side of the flange closest to you. Now, loosen the next two higher bolts on the opposite side of the flange. Then loosen the next higher bolt on your side. Now, loosen the top bolt on the opposite side. Now, do not take the bolt out at this time. Remember, when the flange separates, we want the separation to begin on the side away from you. It's possible, at this time, that the flanges will begin to come apart. If they do, and no release of pressure is present, fine. That's what we want. If the flanges do not come apart, insert a wedge into the flange on the side opposite from you. Tap the wedge in gently, just enough to force out the flanges on this side. Observe closely to see when the flange seal breaks apart. If no pressure is present and the flanges are apart on the opposite side, we can loosen the last two bolts. Be very careful how the wedge is driven between the flanges. These are raised face flanges, and you can damage the gasket faces of the flanges. Never drive a wedge towards the center of the flange. Here is how the wedge should be driven in. Notice the raised gasket face and the position of the wedge. You should use this procedure whenever you want to pry the flanges apart. Once the gasket seal is broken, you should loosen the last two bolts carefully and slowly. Again, remember, as the faces of the flanges open, we want the first crack to be on the side away from you. Continue to loosen the last bolt until it is very loose. Caution, as you loosen this last bolt, watch the wedge on the other side. It most likely will fall out. If the wedge loosens up, it should be removed as a safety precaution. Now, remove all the bolts that were loosened, except for the one used to roll the valve into place during the valve installation. We will again use it to roll the valve out. This bolt should be loose. If the preceding procedure was followed, you can now safely loosen and remove the bolts on the other valve flange. The open valve gate will relieve any pressure that could have been in the line. Remember, if the valve is unbolted, with the gate closed, pressure could be on either or both sides of the gate. Before you remove all the bolts on the other pair of flanges, you should hook up the equipment for handling the valve. You must be careful so that the valve will not roll out and hit you. Be prepared to hold the valve or rig it up so it won't roll before you are ready to remove it from its position. During the removal of the bolts from the second flange, leave one bolt loosely in, opposite the one left in the first flange. Let the valve roll until the stem is down and the weight of the valve is on these two remaining bolts. Remove the last two bolts and remove the valve from between the pipe flanges. Lower the valve to a safe position and remove the rigging. Clean up your work area and the task of valve removal is complete. Although every valve installation or removal is not quite the same general procedures should be followed. The other types of valves shown in the beginning of this presentation are installed and removed in the same manner, except check their individual specifications relating to direction of flow. One important specific to remember if your task is working on a ring joint flanged valve. It is necessary to wedge or pull the flanges further apart to be able to install or remove the valve. This is because the thickness of the ring will require more space to insert or remove. The other procedures remain the same. This concludes the presentation on the installation and removal of a flanged valve. We have some questions for you in exercise number 3 of your workbook.